and welcome everyone to today's webinar, Don't Experiment with Your Safety, Choosing the Right Lab Coat. I'm Ed Rakowski, Editor-in-Chief of the Synergist, the magazine of the American Industrial Hygiene Association, and I'd like to thank all listeners for attending today's event, and especially Bulwark for sponsoring this webinar. Our presenter today is Mark Sainer. Mark is FR Technical Manager at Workrite Uniform Company, a position he has held since joining the company in 2006. He brings more than 35 years experience in the fire and safety industry to his work, including 29 years in technical support, safety standards, and product development for the Akron Brass Manufacturing Company. Now I'll turn the presentation over to Mark.
Thanks, Ed. Appreciate that. Just one note of correction, a recent change in the company ownership. Now I'm officially with the Bulwark Protective Apparel, formerly Workrite Uniform Company. So just want to make sure that was clear. And then on this first slide, just wanted to also note that this is a presentation that's for informational purposes. We don't identify what your safety hazards are. That would be your job to do your assessments and determine what products and garments, PPE, might be most appropriate for your particular situation. So appreciate you all joining me today. And with all that said, we'll jump right in and get started. So today's presentation, I'm going to be talking about FRCP and CP, flame-resistant, chemical splash protective, the protective market and the protective products that are available to help in that particular situation, primarily lab coats. When we look at recent history, we see that there's been a number of hazards and accidents over the years. The one most particularly of note was a recent accident, or not all that recent, a few years back, accident at the UCLA research laboratories where a young laboratory assistant worker was exposed to a pyrophoric material, ignited her clothing, and created severe burns over a large portion of her body. And unfortunately, this particular accident was a fatality, and for the lack of wearing the appropriate PPE, this potentially could have been avoided. And there's been a number of other accidents over the years, Northwestern, University of Hawaii, Texas Tech, a number of accidents, and it's kind of brought to the forefront the need to have better PPE, better protective lab coats, FR lab coats in particular, for the use of these researchers, whether it be in universities or in commercial. There are accidents, there are dangers, hazards out there in the laboratories, and being aware and having the appropriate PPE is a great way to help reduce the potentials for harm and injury. One of the things that I recently got from a university that sent directly to me, somebody that was using one of our new FRCP lab coats, is what you see on the screen right now. And this was almost the exact same situation that happened at UCLA. And as you see in the quotes, pyrophoric chemical was on fire, got under a coat, but it self-extinguished. Clothes underneath were not affected at all. She stated, "I get chills just thinking what would have happened had she not been wearing one of your coats." Totally different outcome than that at UCLA. The exact same situation, exposure to a pyrophoric, which is a chemical when exposed to air auto-ignites. In one instance, no lab coat, clothes catch on fire, and it was a drastic, tragic outcome. In this situation, the exact same thing happened. Pyrophoric chemical exploded, did not catch clothing on fire, did not create the injuries, and the person walked away without having any dangers or any accident or injuries because of the lab coat catching on fire. Night and day difference. PPE does work and can help. When we look at common laboratory hazards, there's lots of them. And two of the most common ones have to do with chemical hazards and fires and explosions. There's lots of chemicals out there, lots of things that can happen, fires, explosions, heat sources, ignition sources, lots of dangerous chemicals, not to mention all the other kinds of actions. But these are ones that can be provide some protection for, and that's where the lab coats can come in handy. Here's a list of just a few of the common lab flammables and combustibles that are out there. We talk about things like acetone, hexane, toluene, phenol, ethylene glycol, and a host of others. There's probably 90-some chemicals out there that can be either flammable or combustible that can create a problem, can create a hazard. If you've got these chemicals, they get released. If there's an ignition source, whether it's a Bunsen burner or some other kind of heat source that can ignite the flammable gases that are released by these, a flash, a flame, you can get an explosion. And if you're not wearing something flame resistant, like a flame resistant lab coat, the likelihood of your clothes catching on fire are very high. And that's what causes the most injury, not the flash itself, because that's very momentary, doesn't take very long. It explodes and it's over. But if your clothes catch on fire, that's when the real damage happens. That's when you get the more severe, more amount of burn injury, and that's when you have significant problems. This is a simulation, or actually just some images of a simulated test that I ran back some months ago, where we took a standard polycotton lab coat, exposed it to a torch flame, short duration flame. You can see how it that's the one on the left, obviously, the white one. You can see how it ignited, caught on fire, spread, and burned rapidly. And this is particularly bad because it was exposed on the front side, and it's going up into the face. We did the same experiment on the coat to the right, the FR coat, hit it with the torch, up and down the front, the sleeves all around, no ignition. It flashed off some of the dyes, but it did not ignite and continue to burn. As soon as we pulled the torch away, no flames, no fire, no heat. So night and day difference what can happen when you get exposure when you're wearing a non-FR versus an FR lab coat. So when we look at chemical splash, that's another version of burn injury. You've got your flash from a fire, but you've also got the chemical splash as another type of burn injury. So you can have skin burns, severe skin burns from chemical splash, as well as from the thermal energy from an explosion or a combustible or flammable flash fire type exposure. In this particular quote here, a young lady was working with a dangerous chemical. She was filtering it when her hand slipped. Solution splashed onto her forearm. She wasn't wearing any protection on that area, no lab coat. And you can see the damage it did to her skin. And her quote was, she learned the hard way. Hopefully others can take that experience and realize they need to be wearing a lab coat. Mistakes happen. Accidents happen. People get injured. You want to have as much potential protection as you can, but it's still got to be usable. It can't be not a suit of armor. And when we talk about chemicals, here's a partial list of many of the common chemicals, lab chemicals that are used out there. Sulfuric acid, hydrochloric acid, hydrofluoric acid, nitric, acetonitrile, ethanol, methanol, lots of different chemicals that you don't want to get them on your skin. You know, they're out there, they're dangerous. You work with them every day. Most of the time they're not a problem, but accidents happen. And that's where you need to have that preventative measure, that have that lab coat, some kind of protection on there. You know, you've got your gloves, you need to have your goggles, safety glasses on, and lab coat. Just one more piece of PPE to help protect you against those accidents that might happen. So what's used out there today typically? Commonly used for chemical splash, you've got rubberized aprons and sleeves. You've got disposables, whether they're polypropylene, Tycam lab coats. and you even go to the extreme, you get complete barrier coats. But are they the right product? Are they the right thing to use? Are they ideal? Well, not really. When they wear these types of garments, when you're looking at the one example here, you've got that rubberized apron and sleeves. They're bulky, they're uncomfortable, and probably one of the most important things, it requires a decision point. That worker has to decide, I'm going to work on something I don't want to get on my skin. I need to go put on something else. I need to go put on that apron. I need to go put on that sleeve. I need to go put on that disposable. Are they going to do it? Are they going to remember to do it? Do they know where it is? A lot of times I've done this experiment 100 times, never had a problem, and so they just don't do it. But it only takes one time. It only takes one bad decision, one slip of the hand to have a problem. We've heard and often find that these kind of products are not used very often, which leaves people unprotected. And a lot of times they are flame resistant. They may be chemical splashed, but if you also have those flammables, combustibles in your lab, they could cause a problem. You've got heat sources, ignition points. These aren't flame resistant. They can ignite. They can catch on fire. So even though they protect against one type of hazard, they don't protect against another. So let's talk about the FRCP lab coat, flame resistant and chemical splash protected lab coats. The flame resistant chemical splash, FRCP, and the CP only lab coats that are have been developed and available from Bulwark, they repel small amounts of inadvertent liquid chemical splashes at atmospheric pressure. And we make a point of spelling out, it's not a suit of armor, it's not a hazmat suit, it's for small amounts, inadvertent splash at atmospheric pressure. We're not talking about large amounts, large planned exposures. Under pressure, if you've got a pressurized system in a commercial operation where there's a break in the line and it's spraying out, not suitable for that, and it's not suitable for all chemicals. It just does not work for everything. Works for a lot of the nasty stuff, which your current lab coat probably doesn't work for any of them. But just wanted to set the stage to make sure we understand what we're talking about. Small amounts, inadvertent atmospheric pressure. So this is a slide that's just a screenshot of a video that we've done to show what happens when we pour a piranha solution, sulfuric acid hydrogen peroxide solution, onto these different lab coat materials. The one on the far left in the circle, you can see that liquid solution just kind of beads up, pools up on top of the fabric, just sits there. In the middle blue fabric, you can see where it burned a hole right through. That's just a regular FR fabric. And then on the far right, it's a non-FR, and you can see it's already started to burn through rapidly. So, that same solution on the two, the one on the right and the one in the middle, not a good solution. It's a reaction. It's going to burn right through onto your skin. The one on the far right, the FRCP, it just pools up on site. And this is the worst case scenario. This is a horizontal plane. When you're working at your bench doing an experiment and something splashes up, it's going to hit on a vertical surface the way you're wearing your lab coat, and it's going to run off. So in this case, worst case scenario, it just sits there and beads up, does its job, keeps it from wetting, wicking through to get onto your skin. So what kind of chemicals does this particular fabric work for? We've done experiments with a whole host of typical chemicals, ones that have been used in the AATCC test method. And you can see the list, the ones that inside the brackets that it works with. We're talking about sulfuric acid, hydrochloric acid, nitric acid, acetonitrile, all those that were on the list I talked about earlier. They're all rated as an A or a B ranking. And what that means is an A or B passes. That means it either has no wetting or wicking through or just barely starts to wick through during the time period where the test is run. the list down below, the bottom part of the list, the non-polar organic solvents, doesn't work for those. It only works for the polars, oxidizers, corrosives, acids. Those that have either medium to high surface tension, medium to high polarity works well. When you look at the non-polars, doesn't do the same job. But what about your current lab coat? 6535 poly cotton, all cotton. That doesn't work for any of these on the list. So you get that whole big group at the top, the really nasty stuff, hydrofluoric acid, piranha solution. It works very well in repelling those, keeping those from penetrating, from wicking, wetting into the fabric. Doesn't do everything, as I've said several times, not a suit of armor, but it's much better than what's being worn today typically. One of the things that we've also done is we've had people ask about other chemicals, solutions that are not on this list. And we've been able to do some testing. We've been able to experiment with some of those that are not on the list and been able to test those as well. So there's some ability for us to do some additional testing. We did one for divinyl benzene that's not on the list for a customer, and that also gets an A rating. So there's the ability to test it as well as the ability for you to test it yourself. You know, we can provide a swatch of fabric if you want to do some experiments with some chemicals that you don't see on here. But again, if you look at standard acids, corrosives, oxidizers, polar organic solvents, those with medium to high surface tension, medium to high polarity, pretty sure it's going to work most of the time. So what you want to do is if it's not on the list, you want to check with us. We can either have it tested or we can get you some fabric to do some testing on your own to see if it works, because everybody's situation is a little different. So if you want to do some testing, you can do that. But again, small amounts, inadvertent splash, atmospheric pressure. Those are kind of the parameters that we look at when we're talking about these lab coats. So what is an ideal lab coat? Well, we talked about if you're working where you have flames or flammables, combustibles, you need to have it flame resistant. This particular coat, the base fabric is a Nomex 3A, which is a splash fire rated, certified to the NFPA 2112 standard. If you're working with chemicals that you don't want to get on your skin, also needs to be chemical splash protective. And it needs to be comfortable. If it's not comfortable, breathable, lightweight, feels good to the touch, and fits right, the workers aren't going to wear it. It could be the best lab coat in the world, but if it's not comfortable to wear, breathable, you can see the air permeability numbers there, almost 200 cubic feet per minute air permeability. Very lightweight, 4.5 ounce, breathable. Comes in both men's and women's cuts so that they fit properly. All those things go into making the ideal lab coat that's going to work best for your situation. So you do your hazard assessment, you figure out what are your needs, and then pick out the lab coat that's going to be best suited for that. We put together a little tool that we can provide that our sales group goes out and talks to people, and you can see it here. You've got a checklist on the far right to determine, do you have a fire hazard? Do you have chemical splash? What are the most important characteristics that you want in a lab coat? And then there's a variety of different options that are out there that you can see which one best fits what your needs are. So that's back to your needs and hazard assessment, figuring out what it is you need, what's going to work best for you, what hazards do you have in your particular lab, and how's that going to work? When we look at the lab market itself, we got some numbers from OSHA. There's roughly 800,000 lab workers across the country. And they're split between the academic higher education labs, research labs, and then there's commercial and government labs. Out of that 800,000, it's estimated that 300,000 of those are in the higher education market, and the other 500,000 in the commercial market. So there's a lot of people out there, and there's been lots of accidents over the years. The Chemical Safety Board has collected data that there's been 260 some odd accidents between 2001 and 2018, and that's been spread across all different kinds of different research facilities. They also have found that there's been 5 fatalities and 490 injuries due to burn injuries, whether it be due to flames or whether it's to chemicals. So accidents do happen. There's been a lot of them out there, and people need to be protected. One of the keys that I don't have a slide for, but I'd like to bring up in my presentation is cost of burn injuries. When you look at the cost of a burn injury, it's extremely high. For every % body burn, you have a day and a half in the hospital. Average stay for a person that has somewhere in the 40, 50, 60% body burn, you're talking about 54 days, cost that exceeds $25,000 a day. Typical hospitalization, you're talking $200,000 to $750,000, and lots of them are over $1 million. It's very expensive, long recoveries, very painful, and the lifetime cost, because there's rehab, all kinds of things, you're talking in the millions of dollars if you get a burn injury, a severe one. And the chances of surviving a burn injury, once you get above that 50% body burn area that's in that second and third degree burn injury, the chance of survival drops significantly, particularly in the older age groups. If you get into the 75% body burn area with second and third degree burn, the older workers, you're talking in the teens percent chance of survival. So you need to keep the amount of burn injury and the severity to a minimum, as low as you can. Otherwise, survivability starts to drop off significantly. And that's what flame-resistant clothing is all about. You don't want to ignite your clothing, because the longer it's exposed to the heat and flames, the more potential you have for severe burn injury, second, third degree, and the amount of area of your body that's injured. Another point that I wanted to make is regarding OSHA. OSHA has some rules. The most basic rule is the employer has to provide the employee with a safe environment. Keep them free from recognized hazards that can cause death and serious physical harm. For example, if there's things that are going to be falling out of the air, you need to have a hard hat. Things are flying around that could go in your eyes, safety glasses, loud noise over 90 decibels, hearing protection. And likewise, if you're potential for an arc flash, a flash fire, a chemical burn, you need to have on FR clothing, chemical protective clothing to work in those situations. And you also need to be aware of the different standards that are out in the marketplace. OSHA is just telling you what you need to do. The standards are what tell you how to do it. So when you're looking for a safety clothing out there, look for the different standards. Look at OSHA to make sure you understand. And you have to make sure your people are properly trained on how to use it and when to use it. And in this case, as I talked about earlier, on the when to use, if it's a comfortable, well-fitting, proper garment, they can wear it all day long. They don't have to make that decision on when to wear it. You put it on when you go into the lab, you leave it on while you're in the lab the whole time, and you've got that protection. You don't have to make that decision point, when to wear it, when not to wear it. So that's kind of the basic rundown on lab coats. There's a lot more we could talk about. We are going to launch a poll question on the type of chem splash that you use. So if we want to go ahead and launch that, we can throw that up on the screen, and then you can reply to it. The type of chem splash does your facility use today, and you can see all the different options. So if you wouldn't mind going through, take the poll. And if you have, once you're finished, if you have other questions that you want to throw into the chat box, feel free to do that. We'll try to answer those after I get done completed and after the poll's done. We'll see what might come up, because I'm sure if you have a question, somebody else has the question as well. Just while you're taking the poll, just wanted to drop back and make the point. There's lots of different hazards in the laboratories, and you have to protect the people with whatever's the proper PPE. In terms of lab coats, if you've got flammables and combustibles, you need FR. If you've got chemical splash potential with the acids, corrosive, polar organic solvents, you need the chemical splash protection. If you've got both, the FRCP coat is ideal for that situation. If you have just chemical splash, there is also a CP version of the coat that is just for chemical splash only. If you don't have the flammables, combustibles, ignition sources, then there's a version of it that just gives you that chemical splash. It's still breathable and comfortable to wear, but it's not FR. So depending on what your need is, you do the assessment. If you don't have flammables and combustibles, ignition sources, the CP version might be suitable. Most people are going to have some of those. They're pretty common in laboratories that you have those types of chemicals. So the FRCP, would fit the bill. And there's also a coverall version. If you have a need for more full body head to toe coverage, if it's in a commercial application, there's a coverall version that does the same job. So there's lots of different options for you, whether it's FR, FRCP, FRCP coverall, CP, lab coat, lots of options to try and give you the protection you need. And frankly, a lot of people are looking for multifunctional garments. So the FRCP kind of fits into that latest trend to get garments that cover more than one hazard. So do your assessment, determine what hazards you have, and then take the appropriate steps to protect your workers with whatever is the right PPE for their situation. Let's see, we've got some people taking their polls here, and I just also wanted to make a statement about the fact that I appreciate the AIHA giving us opportunity to do this presentation. We like to be able to help educate our customers and potential customers on what the hazards are, what available PPE is out there to help protect them, new and innovative things that come along. This FRCP has only been out for a couple of years, so a lot of people may not have heard about it yet. But it's new and different, something that fits a particular niche that people might need. So appreciate the opportunity to discuss this with the group, and I think we're kind of rolling down. We've got a little bit of time left for the poll question, so let's keep filling in those little boxes. I'm looking at mine, and I see most people, or a lot of people are saying all the above in terms of they wear the rubberized splash and the disposables. One of the things that I get asked about a lot or get questioned about is the cost of an FRCP lab coat. Well, it's higher than a 6535 polycotton lab coat, no question about it. But the 6535 basically keeps dust off your clothes, has no protective properties at all. It ignites, it allows chemicals to wick through quickly, and doesn't provide any protection whatsoever. And when you look at the cost of a burn injury, the cost of a lab coat is pretty small. Not the cost of the burn injury hospital costs, but you've got all kinds of other costs that are involved, whether it be insurance costs, whether it be reputation, whether it be loss of funding for research projects. Lots of things can come into play when you look at the real cost and the total cost if one of your employees gets injured. Decrease in morale, all kinds of things. So, it makes sense. It's the right thing to do. Protect your people. Do the hazard assessment. Find what's right for your situation. And I think you'll find that having a lab coat that gives you some protection is going to be the way to go. So how we doing, Ed?
Hey, Mark. We're doing well. This is a good time for us to get into the Q&A portion of the presentation. Just a couple of housekeeping items for everyone on the call. Please, Regina, our host, is going to put up a new poll. Please fill that out. And if you have a question that you'd like to direct to Mark, go ahead and put that into your chat module. If you don't see the chat module in your lower right-hand corner, you might have to hover your mouse down the bottom of your screen. You'll see a series of icons pop up, and you want to click the speech bubble type icon to open the chat module. So we do have a question came in from Dina, Mark, while you were on that the slide about the ideal lab coat, and I think she was asking if those coats are launderable. Could you respond to that?
Absolutely, and that's a great question. We get asked that all the time, and the answer is absolutely it is launderable. The FR in particular has been laundered for years and years, and they're designed to maintain their flame-resistant properties for the life of the garment. It's going to wear out before the flame-resistant properties wash out. In terms of the chemical protection portion of it, that has a little bit more of a limitation. You can wash it, but it's somewhat heat dependent. The hotter the wash temperatures, the shorter duration it'll last. It's guaranteed to last 50 industrial launderings, which are a more severe laundering than if you wash it at home. But just standard, liquid detergents. You don't want any additives, no bleaches, no fabric softeners, any of those kind of things. But it is definitely washable. And one of the things that I try and tell people about the fact that we say 50 industrial launderings, we found that most people don't wash these very often. What we hear people saying, I wash it, 3, 4, 5 times a year. So if you think about that, if you wash it 5 times a year and it's good to 50, that's 10 years worth of use. And when it gets past the 50, it's not like it changes from repels to doesn't repel at all. It just starts to diminish its ability slightly, and only with some of the chemicals. Some chemicals, it'll keep repelling up to 100 laundering. So that's kind of where we stand. And we have laundry instructions we can send out to people if you want more details.
Okay, thanks, Mark. Diana has a question. She asks, are the Lab FRCP lab coats arc resistant? Yes,
absolutely. They are. It's an FR base material. It's Nomex 3A base material. Now, it's not a high arc rating. The Nomex itself was not originally designed for arc protection, but it does have the ability to have arc. It does have an arc rating on it. The arc rating is, I think it's in the 4.5 ATPV calories per square centimeter arc rating, but does provide a little bit of arc protection. Not a lot, but it does provide some.
Okay. Question from Thomas. He says, I understand all employers must do a hazard assessment, but can you share or comment on the rule of thumb, and he quotes, lab workers using more than 1 liter of flammable solvent at a time should wear an FRCP lab coat?
Well, I don't have a direct answer for that one, but I will tell you that there is a tool. It's the Lab Hazard Assessment Tool, LHAT, LHAT, that was developed by the University of California system that they're happy to share with people. And basically what it is you fill in the blanks, what kind of chemicals you're working with, how much you're working with, and you go through a checklist, so to speak, and then it makes recommendations on what would be the appropriate PPE. So that's what I would suggest. And if you need help finding that University of California LHAT system assessment tool, I'm happy to help get you to the right direction. If you can shoot me an email, I can help you get to the right people.
Okay. Corey has two questions. His first question is, what options are there for chemical-resistant lab coats that aren't FR?
Okay, so that, and we didn't get in a lot of detail about it, but that is what we call the CP version. It's a white lab coat. It's made with a spun polyester fabric. It has the same chemical technology applied to it that the FRCP one does, but the base fabric is not FR. So that would be what we call the CP version. So that would be the option for the chemical splash. And it's the same list of chemicals that was on the FRCP that you saw on the screen. It's a white lab coat, but it's not FR, it's CP only.
Okay. And Corey's second question, if flammable materials are used in the absence of a source of flame or an ignition source, are FR lab coats still recommended?
Well, as long as you can guarantee there's no ignition source, anytime you get a flammable material released or you get it on your lab coat or so forth, there's always a potential there could be some ignition source. But, without an ignition source, obviously you're not going to have an ignition. Now, the one thing I would say, caution you on is the pyrophorics. And that's the situation that happened at UCLA and that other example I gave you where the pyrophoric doesn't need an ignition source to ignite. It just needs exposure to air. So, you need to be a little careful about that. But, if there's no ignition source, then, you don't have the flame or the flash hazard, then that wouldn't be the necessary product to have an FR version.
Okay. Diana asks, do you have a CP-only lab coat?
Yeah, I mentioned that a couple of times in the prior questions. Yeah, there is a CP only that's available, and you should be able to find that on the website.
Okay, and Al asks, why do the lab coats have to be blue in color?
Well, I'll tell you a couple of things about that. I'll go back to the genesis of the blue lab coat, the blue FRCP lab coat. When we started working with University of California after the accident at UCLA, they wanted to have a coat that was distinguishable between the other coats out there, and that was a common material that we had used for commercial applications, and so that was a color that they agreed on and we all agreed on, and so that's where it all started. And the color change, it has to do with manufacturing volume. We can't make every color under the rainbow because it's too expensive. These are expensive enough to begin with. So that was the color that was chosen originally, and so that's where it goes. Now, the one thing you will note, there is an FR-only coat that's the same color. The difference between the two, and the way you can tell the difference is the FRCP has a black collar, and it has black knit cuffs. And I didn't point this out in the prezo, and I probably should have. You'll note the black knit cuffs on the FRCP lab coat. They are FR, but they are not CP. The CP technology does not work on that knitted fabric for the cuff because it stretches too much. So, you're supposed to be wearing your gloves when you're working with the hazardous chemicals. So the gloves are either worn over or under the cuff. But that's how you tell the difference. It's got the black collar and the black cuffs.
Okay. Another question. How often do I need to provide PPE training to each employee?
Well, the OSHA is the one that regulates that, and I believe it's supposed to be an annual program. I'm not 100% sure on that, but you would be safe doing it annually at the minimum. But I'd look up on the OSHA rules. OSHA 1910-132 is where I would start, and it talks about training in there. But I would think, just like fire extinguisher training and any of those other things, I believe most of them are an annual event.
Okay. Stephen asks, what is the cost range for FRCP lab coats?
Well, we don't sell them directly. We sell them through our partners, whether it's industrial laundry or the lab supply houses. Typically, they're going to run anywhere from $150 to $200. And, I know people get a lot of sticker shock over that sometimes because they're used to paying $35 or $40 for a polycotton lab coat. But remember, the polycotton lab coat doesn't do anything. It keeps dust off of you. And, one burn injury can burn up $150 real fast. So, yeah, they're a lot more expensive. Now, the CP coat, the one that's not FR, because the base fabric is less expensive, it's about half that price. So you're talking $75, $80 for the CP only, and then in the $150, $200 range for the FRCP at retail.
Okay. And in the future, do you foresee all labs requiring FRCP lab coats versus regular CP lab coats?
Well, I'd like to think so, since I'm in the lab coat business. It's hard to say. A lot of that gets dictated through, either OSHA rules or through industry rules that come through. And unfortunately, a lot of times those rules don't happen until there's enough incidents, enough accidents, enough issues that somebody brings it to a forefront. So it's hard to say. FR got dictated into a couple of the industries, but it took years and years and years before it happened. So hard to say. Don't know.
Okay, Mark. Well, it looks like we got to the end of our questions so far. Just wanted to throw it back to you really quick, see if you had any final thoughts that you wanted to leave the attendees with.
Well, the only thing that I would kind of leave with, and I've mentioned it along the way, accidents happen. There's lots of ways to try and protect people, whether it's eliminating the potential for the accident or adding in engineering controls, administrative controls. But PPE is kind of the last line of defense. It's like your seatbelt. You've got airbags and you got, side view mirrors with blind spot sensors, and you've got anti-lock brakes and all those kind of things. But everybody still wears a seatbelt. That's your last line of defense out there because, things happen. People make mistakes, accidents happen, and it's a small cost. A lab coat is a small cost to pay for avoiding a serious injury. That's kind of the last thought on my mind, that we want to protect people. We want people to end up like that example where the lady said, I get chills thinking about what would have happened had she not been wearing your FRCP lab coat. We don't want accidents to happen, but we don't want people getting injured. So last line of defense is your PPE.
Yeah, Mark, while you were talking, we did get another question from Nellie, who asks, what is available for the polar organic solvents?
For the polar organic solvents. Well, that's what the FRCP works with. It works with polars. It doesn't work with the non-polars. So if you looked on that list that we went back through, can I scroll back through my slides? Will they show? Yeah. So that's the list that I had shown. I don't know if you can see it on the screen or not, but the top part of the list, you can see polar organic solvents: acetonitrile, DMSO, nitrobenzene, ethanol, methanol. Those are all polar organic solvents, and it does work for those. The non-polars, if that's really, I see the question just popped up on the screen for the non-polars. That's a whole different animal. You have to get something that's non-permeable. That means it doesn't breathe, and that's the rubberized aprons or some of the disposables. But on the other flip side is they may not be FR. So if you've got both hazards, it can be a bit of a problem. It's a tricky solution. Non-polars are tough. They have low surface tension, and it just I don't have a great solution for that other than the disposables, might be a solution. But you're back to the decision points. You have to remember to put it on. They can be costly because you use it once, you throw it away. If you're using them a lot, then you're going to go through them in a hurry, and they can get expensive. So unfortunately, as it stands today, don't have a great solution for the non-polars.
Okay, and Corey is asking where he can get the CP coat.
Well, we have a number of our suppliers or our partners out in the market. I don't know if he uses industrial laundry service. People like Cintas, Aramark, those kinds of industrial laundries have access to it. Typical lab supply houses like Fisher Scientific, VWR, they have access to it. So those would be the normal places to go. You can call into our customer service department and ask them. They might be able to give you some ideas in your particular area. But typically, most of the people are going to either one of the big industrial laundries or they're going to somebody like Fisher Scientific, who we've worked closely with.
Okay. All right, Mark, it looks like we've run out of questions. Thanks very much for your presentation today, and thanks to Bulwark for sponsoring today's webinar. And thanks to all of our listeners. The next Synergist webinar, what you need to know about the sample collection and analysis of carbonyls in air, will be held on November 13th. Please register to attend this free webinar at aiha.webvent.tv.
All right. Thank you, everyone. This actually concludes today's webcast. Thank you all for attending. The recording will be available at aiha.webvent.tv. We will send all registrants an email tomorrow with this link. And please visit our event calendar to sign up for future webcasts.